Have you ever built an AI chatbot? You're all proud of it, and then it just gets confused, even when you know the right information is in there somewhere? Well, today we're going to explore a really powerful fix for that exact problem. We're combining two pretty cutting-edge techniques, RAFT and knowledge graphs. It's a combo designed to make your AI not just smarter, but way more reliable.
So if you've ever built a chatbot using Retrieval-Augmented Generation, RAG, you've probably hit this wall. You ask it a totally reasonable question and it gets sidetracked or confused or just gives you a flat-out wrong answer, even though the correct info is buried somewhere in its documents. It's an incredibly common and, let's be honest, frustrating experience.
So what's really going on under the hood here? Well, the core issue has a name: imperfect retrieval. Your RAG system goes out and pulls in a bunch of documents it thinks are relevant, but some of them are just noise. We call them distractors. The AI then has to try and separate the real signal from all this noise, and it often struggles.
Here's how we're going to tackle this. First, we'll look at why standard RAG just isn't cutting it. Then, we'll introduce the RAFT and knowledge graph solution. After that, we're going to get hands-on and walk through building the data pipeline, training a much smarter model, and finally, we'll see our new KG-RAG chatbot in action.
All right, so let's start with that fundamental challenge. The problem isn't just about finding information. It's about the AI being able to navigate all the noisy, distracting information that comes along for the ride.
So to solve this, our solution combines two really powerful ideas for a much smarter approach. And the first of these is a technique called RAFT.
RAFT stands for Retrieval-Augmented Fine-Tuning. And honestly, the best way to think about it is like you're training an AI for an open book exam. You don't just give it the question and the right answer. No. You give it the question, the one correct document, and then you throw in a whole stack of distracting, irrelevant documents. This forces the model to learn how to find the right facts while actively ignoring all that noise.
Okay, the second piece of this puzzle is the knowledge graph, or KG. Now, instead of just storing a big, messy pile of text chunks, a KG organizes information into entities, we call those nodes, and the relationships between them, which are the edges. This structure is so powerful because it lets our system retrieve information based on actual context and connections, not just a simple keyword search.
And when you put these two together, you get a vastly superior system. On the left, you've got standard RAG, which just gets overwhelmed by a flood of sorta relevant documents. But on the right, our new approach uses the graph for super-targeted, intelligent retrieval, and the RAFT fine-tuning gives it the ability to focus only on the correct information within your specific data. It's a total game changer.
So how do we actually build this thing? Well, it all starts with a solid, well-structured data pipeline. This is the foundational work we have to do to turn all those messy, raw documents into the clean, intelligent knowledge graph that's going to power this whole system. Here's the roadmap from start to finish. First, we ingest and clean up our documents. Then, we use that to build the knowledge graph to structure the information. From there, we retrieve both the relevant passages and those all-important distractors. This lets us generate the special RAFT dataset that we need to finally fine-tune our model to ignore all that noise.
And for a real-world project, this is exactly how you'd want to organize your files. See how each major step in our pipeline maps directly to a numbered script? This kind of clean structure isn't just for show, it's essential for managing the complexity and making your work reproducible.
That first script, 01_ingest by pi, it's simple, but it is absolutely vital. Its one and only job is to clean and normalize our source documents. Now, this might seem kind of basic, but it's the foundation that makes sure every single step that comes after it, from KG extraction to dataset generation, is consistent and reliable.
Next up, we model the knowledge graph itself, and the structure is actually pretty elegant and simple. We create nodes for entities like people, places, or concepts, and we create nodes for